value of money changes. The value of money does not remain the same. And I'm saying, assuming here, now, that is year 0 today, and we have 10 years to come. 10 years to come. So we have 1 million shillings today here, shillings 1 million, and here we have shillings 1 million. So we're saying the value of 1 million shillings today, this, it's like, if you remember what I said, assuming someone tells you that I give you 1 million shillings today, or you wait, I give you 2 million shillings after 10 years. I either give you 1 million shillings today, or you can wait, I give you 2 million shillings after 10 years. Which one is better? And we said, holding other factors constant, because there are other factors that can influence your decision. Maybe you are going through a difficult time and you don't care what you're going to get after 10 years, but holding other factors constant, just look at the 1 million now and the 2 million after 10 years. You said you would rather go for the 1 million, because this, it may be, if you determine what is the present value of 2 million shillings expected in future, because remember, this 1 million is in present value terms. This one is in present value. Present value means now. But this 2 million is in future value. This one is in future value. If an amount was be received in future, we say it is in future value form. If it's been received or paid today, we say it's in present value terms. So before you make your decision on whether to go for the 1 million or the 2 million, you're supposed to ascertain what is this 2 million in present value terms, because I'm being promised the 2 million in future value terms. But what is the present value of this 2 million in present value terms? That is, you bring it to present value terms. See, tumeanza kurecord. Oh, okay, yeah. So that was earlier. So what is this in present value terms? So when you ascertain the present value of these 2 million, that is bringing it in present value form, you may realize that it is 0.8 million. So if it is 0.8 million, you will say, I would rather go for the 1 million shillings today. Yeah, are we together? You would rather go for the 1 million shillings today, but you cannot compare 1 million and 2 million. Those two figures are not comparable, because one is in present value terms, the other one is in future value terms. You cannot compare an amount in present value terms with an amount in future value terms. If you want to have a fair comparison, or if you want to form an even ground for comparison, you must either take this 1 million to future value, or bring this 2 million to present value. And the most important thing, it is bringing, okay, either way can work. So, but you must compare the two amounts in same form, either in present value terms or in future value terms. And that is where now the concept of time value of money comes in, determining either the future value of an amount or the present value of an amount. Now, let's say something now about the time value of money. So time value of money, we've said here we have present value, and future value. So present value, we have that direction, and we have this direction. So this is to say, you can work from present value terms to future value, or you can work from future value to present value. When present value to future value, when we are doing present value to future value, we call it compounding. This one you must have done in mathematics, compounding. Compounding, it is determination of a future value from a present value. Determination of a future value from a present value. For example, in our example here, you have been given 1 million. You want to know, if I get this 1 million today, I'm going to invest. Remember, you're not just getting the 1 million and keeping it maybe under the bed. No, you'll get the 1 million and invest somewhere. If you invest, it will earn a return. So after 10 years, you will not just have 1 million, but you'll have 1 million plus a return. So we want to know this 1 million plus the return that you're going to earn, how much will it be after 10 years? That is determining the future value from a present value. And that is what we call in compounding. That is compounding. The other one, we are moving from future value to present. Like in this case, you're being given 2 million shillings after 10 years. But we want to know what is the worth? What is the worth of 2 million shillings 10 years to come? What is the present value of this amount? So you go backwards. Working from future value to present value, we call it discounting. Discounting. This is discounting. Discounting is determination of a present value from a future value. Determination of a present value from a future value. And I've said, when you are given an amount in present value terms and another amount in future value terms, and you are supposed to compare the two, you cannot compare when they are not in the same form. You are supposed either to convert them to present value or to future value and make a decision or make a conclusion. That is all about time value of money. So let's see what we have in the handout. There is a handout I've just shared. There is a handout I've just shared in the WhatsApp group. Kindly check. Kindly check. Have you seen that handout? I shared just a few minutes before the class. I want us to look at it. In case you have a question, you can ask before we proceed. In case you have a question, kindly ask. Okay, fine. Let's. I want to believe you've seen the handout. It's important to respond. Kindly respond if you've seen the handout. Okay, fine. Let's continue. Thank you, Alice and Akin, Alan as well. So up there, you can see the introduction, concepts of time value of money, introduction. A shilling today is worth more than a shilling tomorrow. All what I've explained is what you can find there. Future value techniques. Future value techniques, you can see there we have future value. That is what I've explained. An amount that will be paid or received in future, we call it a future value. Then we have present value techniques. Present value, I've said, is an amount today. As an amount today, present value. Compounding techniques, but I'm not saying you are going to make sure you go through this, the theory part, at your own free time. But this is what I've just summarized. There is no need of repeating. I just want us to walk through. Compounding techniques, we've said, okay, this is what we did in mathematics. Simple interest and compound interest. So again, that is not important, so much important. I just want us to look at the, but let's, we are under compounding techniques. Here we've talked about two concepts, the concept of compounding, the concept of discounting. So I want us to start with compounding. That is compounding techniques. That's the reason why they are saying compounding techniques. Compounding techniques. So we start with the compounding techniques, number one. Determination of a future value from a present value. Compounding techniques. compounding techniques. Now, we start with future value of a lump sum. Okay, in here, we will not focus too much on the illustrations that we have there in the handout. I want you to make short notes. I want you to make short notes as we continue. I have some handwritten notes here that I want to share with you. So just write concepts of compounding, or compounding techniques, and we start with the first one: future value of a lump sum. 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 Alan? Okay, I will share. But the handout is more summarized. So we start with future value of a lump sum. Now, when you talk about, the most important thing here to understand is what is a lump sum? What is a lump sum? A lump sum, this is an amount that is received or paid once. An amount that is received or paid once is what we call a lump sum. For example, let's say if you pay or receive 2 million shillings today, that is a lump sum. Or if you invest, let me show you. Let's first understand. We have two things here. We have a lump sum. We have a lump sum. And we have an annuity. And an annuity. So here, let's say we have periods. We have period 1, 2, 3, 4. So we have amounts. Let's start with lump sums. Lump sum amounts. Lump sum. Let's say in year 1, the amount is 300,000. In year 2, it's 550,000, 600,000, and 700,000. These are what we call, all these are lump sums. Okay, let's have annuities. Annuity amounts. These are like installments. They are equal: 400,000, 400,000, 400,000, 400,000. So annuities, they are equal amounts received or paid regularly. Equal amounts received or paid regularly. And when we say regularly, we are saying it's either monthly, weekly, semi-annually, yearly, quarterly. That means like every month you are paying or receiving 400,000. That is an annuity. Or each year you are paying or receiving 400,000. That is an annuity. Equal amounts received or paid regularly. Lump sum amounts. Lump sum amounts, you're saying this is an amount which is received or paid once. They do not repeat themselves. For example, in year 1, you'll receive 300,000. In year 2, you're getting 550 or paying or 550. Year 3, 600. Year 4, 700. Maybe let's say year 5, 300,000. You cannot say that since 300,000 is appearing twice, that it is an annuity. No, it is not an annuity because it has not been received regularly. You've received 300,000 after some other cash flows have been received here. Are we together? So all these are lump sums. All these are lump sums. However, if, for example, If you get 300,000 here and 300,000 here, we have two 300,000 that follow each other, this one and this one. This one will be referred to as an annuity. This is an annuity. Year 1 and year 2, or period 1 and period 2, we have an annuity of 300,000 because they follow each other. Yeah. But if the 300,000 occurs after, let's say, for example, here we have 700,000 and here we have 300,000. So in year 1 and year 3, we have 300,000. These are not annuities, they are lump sums, because in between them, there is a figure that is different from them. I want to believe that is very clear. That is clear, a lump sum and an annuity. This is a concept that we are going to use a lot in financial management, and that is why I want you to be able to differentiate lump sums and annuities. Again, so this was 6. Let's say this was what? This was 500. Let's say now, yeah, 300,000 there. 300, yeah, let's say 300,000 here. So in year 4 and year 5, the 300,000 becomes an annuity because they follow each other. We have two 300,000s that follow one another. So they are annuities. So I want to believe that is clear. That's okay? Okay, fine, let's proceed. So we now looking at future value of a lump sum, future value of this kind of cash flows, future value of this kind of cash flows. So when you want to determine the future value of a lump sum, future value of a lump sum, future FV, its future value of a lump sum is equals to present value, or let's say principal, what you are used to, principal times 1 plus r power n. Principal times 1 plus r power n. And this is what you call present value. Present value. This principal figure here is what we call present value. Let's see. Let's see what we have in the handout there. Check what we have there. Where are we? Where are we? Future value of future value of a lump sum should be there. If you look at the handout, you'll see using tables to find future value. Equation for finding future values of a single amount is derived as follows. How it is derived is not so much important to us. The most important thing is this. Yeah, this is how we get the future value of a lump sum. Future value of a lump sum is equals to principal into brackets present value times 1 plus r power n. This factor here, this factor 1 plus r power n is called what? Future value is called future value interest factor. This one is called future value interest factor. Future value interest factor. That factor is called future value interest factor. This one is very important. 1 plus r into bracket power n. So here we can say where FV is future value, R is the discounting, or not discounting rate, but rate of return. Rate of return. It's important for you to write this formula. Just write this, just write that. Rate of return is like the interest rate. Rate of return is like the interest rate. Yeah. Do we have an example there? So the example, yeah. That there should be an example somewhere. Yeah, there is an example there. Look at that example. They're saying, assume that you've just invested Kenya shillings 100,000. The investment is expected to earn interest at a rate of 20% compounded annually. Determine the future value of the investment after 3 years. So, okay. Let's look at that. We are doing that illustration, that example. We're saying, assume that you have invested shillings 100,000. That is the present value. That is the principal. The principal amount, which is present value amount, is Kenya shillings 100,000. 100,000. Then the investment is expected to earn interest at the rate of R is 20% per annum. This per annum is very important. Okay, it is not given. They have not said per annum, but we say when you get a rate of return, where the period, whether the per annum, per month, semi-annually is not stated, the standard measure is per annum. So unless it is specified like semi-annually or what, you should take it as per annum rate. So per annum is 20%, compounded annually. Determine the future value of the investment after 3 years. N, we should have said N here, N. N is equals to number of periods. Number of periods. Kindly have that. Number of periods. Number of periods. Make sure you write that. So here, our period is 3 years. We are investing for 3 years. So future value we are saying is equals to present value 1 plus R power N. So future value is equals to 100,000 times 1 plus 0.2 power 3. Power 3. So get the value of the investment after 3 years. Value of the investment after 3 years is how much are you getting? There are people, no, but you must be knowing how to put this power 3 in calculators. Anyone who doesn't know, you will be assisted. Now, for example, we have two answers here. We have 172,800 and we have 106,120. Alice, I'm doubting your answer. At a rate of 20%, even in the first year, we are going to earn 20,000. Because first year one, we will say 20% times this. Times 100,000. That is 20. That means it's more than 106,000. So 178, probably 172,800. 172,800. At least repeat your calculation. Okay, yeah, 172,800. That is what you're supposed to do. Another method of getting this. Another method of getting this is or. So here you say or a very long method. You'll say period here. Period 1, 2, and 3. Amount. Let's say 100,000. No, will that give us? No. No, that is the only way. Okay. The other method is where we say, but this one is very long. Where you say here it's 1 plus 0.2 The figure that you'll get here, you bring it here. Then you continue, but that will not apply in this case because we are only investing one. So you can continue, you grow by that rate, So just stick to this. Just stick to this. Any question before we continue? We want to proceed. Okay, number 2, future value of an annuity. Future value of an annuity. Future value of an annuity. Future value of an annuity, and you have seen how we get the future. I've explained what's an annuity. Future value of annuity. Future value of annuity. Now, a future value of an annuity, just like we've said, you get the annuity. It's an annuity when the amount occurs repetitively, but regularly. So future value of an annuity is computed as follows. Without wasting a lot of time, future value of annuity is equals to the annuity. You get the annuity amount times annuity amount times. So we have the future value annuity factor. The future value annuity factor, you say 1 plus r power n minus 1 over r. That's how we get the future value of an annuity. 1 plus r, and write these formulas because the way they are in the handout. Okay, they are very much simplified in the handout. Just write what I'm writing on the board. Yeah, it's there, but write. Future value of an annuity is equals to annuity times 1 plus r into brackets power n minus 1 over r. This factor here, the factor 1 plus r power n minus 1 over r is called future value interest factor of an annuity. Future value interest factor of an annuity. What have they said there? Future value interest factor of an annuity. Future value interest factor of an annuity. This one. Now, we have tables. We have tables where these factors can be read from. Like you remember what table do we have? We have math table. Do you people know what's a math table? Or maybe what we call what? Normal curve, normal distribution curve. We have tables. We have tables where you can read these factors. When we go to discounting, I'm going to share the tables so that we can see. But for future values, the tables for compounding, it's not widely used in financial management. So just get these formulas right. Yeah. So any question here? There is nothing to explain. We know R is the rate of return or the interest rate. N, it's the number of periods. So there is nothing to explain. Let's go to what? Let's have an illustration. Do we have an illustration there? From the above example, there is a statement that says no. We have an example. What is the value of shillings 100,000 investment annually at the beginning of each of the next 5 years at an interest of 12%. Are you there? Have you seen that example? And finding future value of an annuity. Oh, that's due. Sorry. What is the value of 100,000 investment annually at the beginning? That's an annuity due. We are coming to that. I want us to have an illustration on the illustration on future value of an annuity. Okay, let's say from the above example, there is a part that is missing here. There is a part that is missing, but all in all, let's just write an example there. Just write something. Just write an example, an illustration. Say an investor intends to invest. An investor intends to invest shilling 60,000 at the end of each year for 4 years. An investor intends to invest shilling 60,000 at the end of each year for 4 years. At the end of each year for 4 years. Full stop and say, the investment will earn interest. The investment will earn interest at a rate of 20%. The investment will earn interest at a rate of 20%, compounded annually. The investment will earn interest at a rate of 20%, compounded annually. Compounded annually. Full stop. Determine the future value. Determine the future value of the investment. Determine the future value of the investment after 4 years. Determine the future value of the investment after 4 years. Determine the future value of the investment after 4 years. After 4 years. Now, future value of the investment. Now we start. This is how you should be approaching these questions. You first analyze the question. For example, here we are saying amount to invest is 60,000 at the end of each year. So annuity. We say annuity. Shillings 60,000. Annuity shillings 60,000 at the end of each year for 4 years. Period is 4 years. 4 years. Then the investment will earn interest at a rate of 20%. So 20% per annum. So we want the value of the investment after 4 years. So future value of annuity is equals to the annuity times 1 plus r power n minus 1 over r. So here you say 60,000 times 1 plus 0.2 power 4 power 4 minus 1 over 0.2. So get the value of the investment after 4 years. Then I show you another way of doing it. Get the answer, get the answer. Get the answer. Three 322,080. 322,080. Another person. 322,080. Another person. Alice, okay, that's fine. Now, there is another way of doing this question. So this is now, you say period, period, 1, 2, 3, 4. Annuity or amount. Remember, this person is investing 60,000 at the end. Yeah, at the end of each period. 60. 60. 60. 60. At the end of each period, this person is investing 60. So here you say 1 plus R power n. If we want to treat each amount as a lump sum, then here we will have future value. Future value. So here we will have 1 plus R. 1 plus R. This is 0.2. 0.2. 1 plus 0.2. 1 plus 0.2. 1 plus 0.2. 0.2. 1 plus 0.2. So before that, we know we've not put n. That is what I want to illustrate here. That is what I want to illustrate here. So we are 0. We always start at 0. 0 means now 1, 2, 3, 4. We're talking about 4 years, which is 1, 2, 3, 4. So here we have at the end. We are investing at the end. So at the end of the first year, 0, 60, 60, 60, 60. I want us to put n. So this 60 that you've invested at the end of year 1, how many times will it earn interest? The 60 that you invested at the end of year 1, how many times will it have earned interest at the end of year 4? It is here. 1, 2, 3. We have invested 60 here, so it will earn a return here, a return here, and a return here. So you say power 3. That is power 3. Then the other 60 at the end of year 2 here, it will earn interest here and here. So you say power 2. The 60 that you invest at the end of year 3, it will earn interest once. So you say power 1. And the last one, the 60 that you are investing at the end of year 4, it will have earned no return. So you say power 0. So multiply and get the total. If you multiply and get the total, we should be getting the same answer as this. We should be getting the same answer as this. So the reason why I just want you to get the concept, the concept here of power what, power what, power what. So 103,680 must be the first one. 103,680. 103,680. 86,400. 72,000 and 60,000. So get the total. Get the total. $322,088. Yeah. So almost the same as what we have here, just because of rounding off, that's where there are differences. So is that okay? Let's proceed. Let's do the next one, then we go for a break. The other one is future value of an annuity due. Future value of an annuity due. Let's wrap this. Future value of an annuity due. Now, what we have talked about here, it is an annuity that occurs at the end of the period. So here we had 60. If an annuity occurs at the end of the period, like in this case, that is what we've done in part B. But now we have what we call, okay, fine, Alice, 080, okay, fine. So future value of an annuity, this is when the amount is invested or paid at the beginning of the year, at the beginning of the year. For example, if our 60 here, 0, 1, 2, 3, 4. If the investment is done at the beginning of the year, for example, here 60, 60, 60, 60, 60, we call it 1, 2, 3, 4. This is not there. We call it an annuity due. So an annuity due is an amount that is invested or paid at the beginning of the period. And this will change because now, like here we had said, this is power 3 because we counted here 1, 2, and 3. But if it's an annuity due, we will now have 1, 2, 3, 4 because we are going up to the end of year 4. Because we are going up to the end of year 4. So the amount that we invested at the beginning of year 1 here will earn interest 4 times. 1, 2, 3, 4. The amount that you invested at the end of year 1 will earn interest 1, 2, 3. This will earn 1, 2, and this will earn 1. So the entire thing will change there. But now, how about when we are using the formula? When we are using the formula, this is how we get the future value of an annuity due. So here we say future value of annuity due is equals to annuity times 1 plus r power n minus 1 over r. Then we add another factor here, 1 plus r. 1 plus r. 1 plus r. 1 plus r power n minus 1 over r times 1 plus r. So this is now what gets us for the element of investing at the beginning of the period. So you can write that. And then we have an illustration So back to the handout, there is an illustration. Finding value of an annuity due. We have an illustration for that. If you can check in the handout, they're saying, assuming the above example, the investment is made at the beginning of the year rather than at the end. So example, what is the value of shillings 100,000 investment annually at the beginning of each of the next 5 years at an interest rate of 12%? So let's do that. So we're saying, what is the value of shillings 100,000? So annuity, the annuity is 100,000. What is the value of shillings 100,000 investment annually at the beginning of each of the next 5 years? The period is 5 years. Interest is 12% per annum, and it's at the beginning. So future value of annuity due is equals to the annuity. And you need to be writing these formulas every now and then. Every time you're doing a question, kindly write the formula. Even if you know the formula, just write it. So annuity times 1 plus r power n minus 1 over r times 1 plus r. So annuity is 100,000 times 1 plus 0.12 power 5 minus 1 over 0.12, then times 1 plus 0.12. So get the value. Then you're going to use this method to see. So how much are you getting? 711,518.9. 711,518.9. Now, using this method, we will have this. We will have here 0 here. 1, 2, 3, 4, 5. And remember, The reason why we are starting at 0, you must count 12. Oh, someone else is getting 424, eh? 711, 424. Okay. Another person? A third person? Okay, let's continue as we wait. So, 513, 518, around that range. Now, so I'm saying we start at 0 because we must count 518. Okay, fine. Let's go with 518. We must count 12 months before we call it a year. So we are saying we are investing 100,000 at the beginning of each year. 100,000, 100,000, 100,000, 100,000. Remember, the end of year 1 is the beginning of year 2. So this 100,000 here we are investing at the beginning of year 2, which is the end of year 1. So we are saying this first 100,000 that was invested at the beginning of year 1, how many times will it earn interest in a period of 5 years? 1, 2, 3, 4, 5. So you say power 5. The other one is power 4, power 3, power 2, and power 1. The last one that we are investing at the beginning of year 5, it will also earn interest during year 5. So at the end of year 5, it will have earned once. That is why we are saying power 1. If you do the future value here, you're supposed to get almost the same answer as what you're getting here. So just check whether you're getting the same. On 76 to 34 point you can, okay, in this case you can round off. In this case you can round off to whole numbers. You can round off to whole numbers. In this case, there are situations whereby the decimal points will be required. So let's round off to whole numbers. The first one then should be 176 to 34, 157, 352, 157, 352, 140, 493, 140, 493, 125, 440, 125, 440, and 112,000. So get the sum. $711, $519. $711, $519. Now the reason why we are doing these two methods, this is very short. This is like a shortcut. But we are doing this method so that you can get the concept. Because there are questions that will tell you that the amounts were invested at the beginning, the amounts were invested at the end of the period, this and this was happening. So this one is very important. Kindly get the concept. Then after the break, we will look at discounting techniques. Discounting techniques. After the break, discounting techniques. Discounting techniques. So let's have a break of like 5 minutes. And as we've said, discounting it is this determination of present value from a future amount. Determination of present value from a future amount is what we call discounting. Or rather, yeah, discounting. So we start with the first one. Present value of a lump sum. Present value of a lump sum. Present value of a lump sum is the first one. A lump sum still the same thing as we've said. An amount that is paid or received once is what we call a lump sum. So how do we get the present value of a lump sum? Present value just say PV, present value of a lump sum is equals to future value times 1 plus R power negative n. 1 plus R power negative n. So look at this factor now. Look at this factor now. Under compounding, we were saying power n, positive n, because we were moving forward. But now, under discounting, we are saying negative, because we are moving backwards. So get the difference. Present value for lump sum is equals to future value times 1 plus R power negative n. So where this is future value, R we said is the required rate of return. N is the number of periods, as usual, number of periods. Now this factor, the factor 1 plus R